My name is Sasha Servan-Schreiber, and I hope to convince you by the end of this talk that verifiably private AI is super important for the future. So who am I? I finished my PhD in cryptography at MIT this year, and now I'm the co-founder of Tinfoil, where we're building a verifiably private AI platform. And I've been thinking about privacy and AI for a couple years now, starting in grad school while I was doing my PhD. So what is the problem? The problem is that AI needs a lot of access to contextual data about us, which often requires giving AI tools a lot of sensitive and private information. And if you've been following the news lately, there's definitely an uptick in concerns around data privacy and AI. A couple years ago, Samsung banned ChatGPT internally after employees leaked sensitive code to the chatbot. And recently, Sam Altman pointed out the fact that legal confidentiality doesn't exist when you use ChatGPT as a therapist, which a lot of people do. And there's a growing concern about what happens to our data when we use AI tools. And so, unfortunately, in the short term, there's only really one solution we have, which is either to limit or ban AI usage in sensitive contexts, which isn't great. We definitely want to use AI tools, and worrying about how our data gets used when we use these chatbots is definitely not, shouldn't be a problem. And, chatbots are almost a tool of yesterday. Today, we have recorders that monitor everything we do on our computers to give us summaries and context, look at our Zoom meetings. And tomorrow, we might have brain chips that monitor our thoughts and record everything we think. So in an ideal world, we do want to have very powerful AI that runs in the cloud on big GPUs, so it's super powerful with big models. But we want to have, ideally, very clear and auditable data privacy policies. What I mean by that is that users should be able to check what the data privacy policies are and remain in full control of their data at all times. And more importantly, we want some kind of technological enforcement of these privacy guarantees, not legal contracts or privacy policies that could change at a moment's notice. And so, to formulate the question a bit differently, can we have AI tools that run in the cloud and are very powerful, but have the same privacy properties as local deployments? So can we have privacy of local AI with the convenience and scalability of the cloud? And it turns out there is already a solution to this today based on hardware security primitives. In the latest generation of NVIDIA GPUs, you can turn on a confidential compute mode that exists on Hopper and Blackwell GPUs that encrypts all the data in use, even from the operator themselves. So even though this is running on a cloud server somewhere, the server cannot see what the computation being performed is. And so all data gets encrypted to this secure enclave, and there's no performance overhead because we're still using super powerful NVIDIA GPUs, and all the security claims stem from the hardware, not from privacy policies. But when you use these tools, there's a really important factor that comes into play, which is verifiability. How do you ensure, as a user, that the AI model is actually running on secure hardware and providing a secure enclave? And why is this important? Well, if you're sending data to the secure enclave, how do you know that this enclave isn't fake or in sending all your data to some hackers or exposing it in other ways? Turns out these tools and hardware mechanisms already come with a solution for this, called remote attestation. You can think of this as a hardware proof that gets sent back to the client and gives the client the ability to check that this is indeed valid NVIDIA GPUs with the confidential compute mode turned on. And only if this proof checks out do you send your data for processing. And so this kind of solves the first problem of checking the integrity of the hardware. But there's a second problem here, which is how do we ensure that the code, the actual program running on the secure hardware, doesn't expose my data in some ways? So for example, what if the code is somehow logging my data or is compromised in some way by a hacker and sends all the data to the hacker? So even though it's running in a secure enclave, the program itself might be malicious or compromised in some other way. And so this is where you have to have an end-to-end auditability and transparency layer. What this means is the way this is solved typically is by having the code committed to on a public transparency log. And the same code that is running in the enclave is publicly auditable and available to anyone. Then, before connecting to the secure enclave, the client can check the hash of the code committed on the transparency log against the hash of the code running inside the secure enclave environment, which is already provided as part of the attestation. And only if these two match do we send any data for processing to the enclave. And what this guarantees is that anyone can be sure that the code is actually doing what it's supposed to be doing at any point in time. So if this is available today, why is nobody using this yet? There are a couple reasons for this. The first one is that it's really complicated to set up these hardware security mechanisms, given how cutting edge this technology is. And the second reason is that, like I said, this is only available on the latest generations of NVIDIA GPUs, namely H100, H200, and B200 GPUs, which are in very high demand and still very hard to get. So we're in the very early days of what's possible with AI infrastructure, especially when it comes to privacy. But industry standards are evolving quickly. Apple Private Cloud Compute last year pioneered this idea of having private AI inference. WhatsApp recently released private processing for their AI model in WhatsApp using similar hardware-backed technology. And OpenAI and Anthropic are thinking about how to deploy secure hardware mechanisms to also make their chatbots private. And at Tinfoil, my co-founders and I are working on making this easy to use and deploy. You can actually check us out today. We're at chat.tinfoil.sh, where we have a demo running. Thank you.
We know about AI, we know about AI agents, but what about the internet of AI agents, the agentic web? And the World Wide Web has remained open and neutral. The question is, who will keep the agentic web open and neutral? Now, if you compare that with the early 90s, with the birth of Tim Berners-Lee's World Wide Web, there are some powerful forces leading to fragmentation and control. Companies were launching proprietary browser extensions. There were walled gardens created by AOL and CompuServe and so on. And companies were rushing to patent certain technologies. And the way Tim Berners-Lee at CERN and then at MIT was able to keep the web open is by making sure HTML and HTTP and URLs are in public domain. He launched the World Wide Web Consortium to build open standards and open recommendations. And he very carefully managed the different commercialization pressures and really preserved the neutrality against big interests. So the key lesson from the 90s is that really good technical teams with technical decisions, a governance that involved many stakeholders, and legal frameworks around it has given us today's open and vibrant web. But today, for agentic web, the challenge is very different. There are many companies that are doing some fantastic work. They have already captured part of the market. Digital rails already exist. Back in the 90s, rollout of the broadband was relatively slow. But today, you can go from 0 to 1 billion users in a matter of months. And there's a risk that even though there are open standards, there could be locks because of very specific network effects and reference implementations. Despite all these challenges, the good news is that most companies are launching very open standards and open protocols that you have seen in the agentic web, such as MCP, A2A, NL Web, Project Nanda, and so on. So what does neutral and open mean for agentic web? The very first one is universal interoperability. Any agent should be able to talk to any other agent, independent on which platform they're on, which LLM they're using, and what technologies they're using. There has to be a permissionless innovation where developers can build agents without approval from any particular platforms and launch wherever they are. Just the same way in the 90s and even today, anybody can start a website and any browser can connect to any website. We also need user sovereignty, where people control the agents and their data, as opposed to the other way around. And there has to be some transparency in protocols but there's no black box API that could be swapped out without their knowledge. The opposite of open and neutral web would be a walled garden agentic web, where there's an agent apartheid. There are these siloed segments of the web where agents can talk to each other. There could be platform taxes. You have to pay 5, 10, 30% of your agent store commissions. There could be invisible algorithmic controls, where the visibility of your agents can be throttled. And there could be data imprisonment, could make it very difficult with portability if memory, data, context, tools, and capabilities are locked away on one organization's servers. So, how did the World Wide Web remain open, but some other ecosystems became highly siloed? If you look at the birth of operating systems on smartphones, in the beginning they're very open, but over time they became highly controlled because of store policies and service dependencies. And similarly in social media, although many platforms had open APIs, once they grew large enough, they had enough network effects and they didn't have incentives to stay open. So as you can see, open protocols and open source is not enough. There could be implementation capture because certain reference implementation just pick up a lot of speed. There could be service dependencies because agents need identity, payments, discovery, and whoever controls them can become choke points. Again, early network effects that could happen within a matter of weeks or months after launching a particular product can discourage those organizations to be becoming open. And then finally, there could be geopolitical or regulatory competitions, geopolitical competitions or regulatory issues that lead to very non-compatible policies and could make very difficult for agents to talk across each other to overcome the hurdles of the geopolitical or regulatory barriers. And why does it matter? Why do we need to keep the agentic web open? It's all about innovation and democracy. Clearly, the massive economic impact, there could be $1 trillion economy of agentic web, just like we have $1 trillion economy in the World Wide Web. But we have to do that without creating new rents, and make sure that there's global competition. The best ideas should win. It has to be innovation catalyst. We have to, for small companies and researchers, we have to create a level playing field. And there has to be some democracy. I think if there's algorithmic, and there has to be some democratic values. If there is algorithmic dictatorship, it will make it very difficult for agent to serve us as opposed to we serving the agents. And of course, we need global equity because developing nations need a shot at developing their own internal agentic webs. So this is what we have been doing at MIT for the last 10 years. This has been my research of my team at MIT. We call it Project Nanda. Nanda stands for Networked AI Agents in Decentralized Architecture. And it has 3 phases, the foundations, which is like registry and index, identity, reputation, and so on. The second phase is agentic economy, agentic commerce. And the third is agentic society, where you could imagine it's not just about agents becoming very secure and having financial interest, but the agents can come together and create new universities, new stock markets, new justice system, and so on, and there'll be new emergent behavior. So at MIT and through our nonprofits, we have been working with many partners now, 15 different universities, dozens of companies and startups and other organizations to see how we can contribute to the open agentic web. And what are the key elements of efforts that we are working on for the last 10 years? First one, of course, is the universal interoperability. The second one is critical, the notion of agent facts. Every agent needs to have its own digital passport. And unlike today's web, where our identity is split across our financial life, our health life, our social media, we think in the agentic world, we'll have a unified portable identity system. And it's also credential, just the way when you travel with your own passport, you don't have to ask somebody else's permission. When you show up at the border of another country, they can validate that it's a credential passport. And as you cross the boundaries, it gets stamped and there's automatic trace of where you have been for auditability. And the agents need to have similar autonomy and portability and ability to have an exchange between two agents. The third one is edge autonomy. We shouldn't be the current mental model where agents are simply a software service or an app plus plus is a wrong mental model. We think agents will be more like our phones. They have an edge autonomy. They can work on edge devices and phones and laptops and cars and microwaves, and they could be disconnected from the internet. So they become truly autonomous locally. And then finally, the decentralized discovery, because we need to have a DNS, a new ICANN for all the trillions of agents that are out there. But it'll be strange if a single organization somehow controls the phone book for discovery and authentication of these agents. So I think we have a choice before us. We have to act now or accept oligopoly. Um, and I think all of us together, as developers, as researchers, as policymakers, we have a goal to make. We have a goal to keep the agentic web open and neutral, because the window to keep it open is closing very soon. Thank you.
My name is Jeremiah Aoyang. I'm one of the general partners at Blitzscaling Ventures. I do early stage investment in AI startups, writing $500K, $1 million checks, or even pre-seed smaller checks. We've invested in companies like Crew AI, Composio, Skyfire, and many other consumer things. So let's talk about building an enduring AI application or startup. Right now, the technical moat in the AI space, according to a poll that I polled founders, is only a few months, weeks sometimes. It used to be that a technical moat could last for years. So I wanted to give you some advice on what we're looking for and what we're seeing with companies that are building enduring business models. And this really is about the future of AI agents. So the one thing is we look at the culture, and the culture of these startups is AI native, where they turn to AI first for every single application. And one of the startups we backed is Crew AI, and they're moving at incredible speed. So they are open source agentic enterprise platform, and they are already in 60% of the Fortune 500. Now here's the wild thing. They're only 20 months old. They have 30 employees, humans, but they have 300 AI agents. That's a 10-to-1 ratio of AI agents to humans. And sales, HR, EA, chief of staff, they all have to use agents, and they report about it at the team meeting every week, how they're using AI agents. So that's expected in the space, that you use AI first for all of the tasks and techniques that you need to do. And that culture is kind of required to move at the speed, the breakneck speed that's happening now. So that's kind of this expectation on that culture. The second thing, number two, in the future of AI agents is to ensure that you have access to some form of proprietary data. Proprietary data is a moat, and it's even more secured for you if you have an actual contract, a legal contract with whoever is granting you that access. Now, in the age of synthetic data, you might be thinking, well, I could just create this data and generate it. It's not quite the same. So if you can find a deeper version of quality content that nobody else has access to, that gives you that advantage. There's four things we're going to talk about. So the third one is called a viral strategy. Now, this is not a tech talk. We're talking about your business strategies. Again, there are 40,000 AI startups. The website, there's an AI for that.com, naturally. What other website would there be? Lists 41,000 actual AI projects. So you're probably competing against 100 other AI projects. There's no technical moat. Remember, there's no technical moat. So you need to have the business strategies in place to win this market. So the third thing that you need is what we call a viral effect. And this truly is the hallmark of Blitzscaling. This is the name of our firm, and it's based upon a famous book called Blitzscaling, right? And so the key strategies are viral effects. Now, viral effects happen in a couple different ways. First of all, there's organic word of mouth. Your customers and users are talking about your product, perhaps at an event like this in person, or maybe on social media, or maybe GitHub rankings. The second strategy of a viral effect would be product-led growth. It's actually built into the product, designed to spread. And it can spread, let's just imagine enterprise. It can spread from user to user in one department. It could spread from department to department, or it could spread from company to company, or it could spread up and down a value chain of your partners. By the way, the best ones that have spread, like Slack, DocuSign, any cloud platform, those spread across all four. Slack is the winner. There's at least 10 different companies doing enterprise collaboration, even in B2B, but Slack won that market because they spread so fast. So that's a viral effect. There's a third type of viral effect we talked about, word of mouth, product-led growth. Third kind is called a distribution strategy. And this is when you have a partner. Maybe it's a cloud platform. Maybe it's a management consulting firm like Accenture, Capgemini that pushes your product, or an SAP platform or Microsoft that recommends your product for you. So those are the three strategies when it comes to your viral strategy. That's critical to survive. Again, there's no technical moat more than a month. You must have these business strategies. Ready for the fourth? This is the final one. This one's called a network effect. People often conflate a viral effect and a network effect, but they're different. So a viral effect is about it spreading, your product spreads with low advertising, low marketing, and low sales efforts. A network effect is different. It means that the value that's accruing for all the users increases as every new user or client joins. So, for example, Uber is useless if there's no drivers or no passengers, but the more drivers and passengers you add, the value increases for all. Same thing with eBay, Craigslist, any social network, any financial rails, or any communication platform. So a network effect means the value increases as more people participate. In the AI space, one of the most natural network effects is a learning effect, where the AI learns because of what is happening by garnering the data. By the way, I don't actually consider that useful because every AI startup has a learning effect. So can you have a data effect or an app effect or other types of ways, maybe a two-sided marketplace, three-sided marketplace, maybe an app platform? Maybe you have open source templates, or maybe you're the single platform that everybody uses as kind of a constraint hold, and everybody has to flow through that. For example, Nanda from Professor Rao, he's building that product as a protocol for decentralized agents. That is a form of a network effect if everybody adopts that protocol, right? So those are all examples of a network effects. There's over 6 types of network effects, and it's on our blog post that you can find that. So I came here to tell you, you're competing in a market with 40,000 AI projects, and it's growing about 1,000 per month. It's insane. And by the way, don't forget that many AI projects are now being created by AI. You're competing with AI. So there's 4 things you need to do to become relevant in the future to win your market. I talked about having that culture being AI native, right? Native for AI first. Number 2, having access to proprietary data that nobody else has. That's a moat. Number 3, we talked about viral effects. Your product spreads with low marketing, sales, or advertising. And number 4, garnering network effects means the value increases as every new person or customer joins. And that's how you become relevant in the future of agents. Thanks a lot.
I'm Gökçe Yıldırım. I'm the founder and CEO of Event Creativity, and we started a company in 2020 with healthcare in mind. My background is all in orthopedics for 20 years, but having worked in medical devices and having worked on robotics, additive manufacturing, AI, and all the different areas, really what healthcare lacks right now, which is a big concentration in healthcare, is being language models and reports and radiology reads for cancer, etc. What's really missing is surgical planning. So I think surgery is often overlooked in healthcare. It's mostly drugs and delivery of healthcare, but not so much sort of what happens in the surgery where there's the highest risk. I'm just talking through as I'm waiting, but we'll get there. Essentially, what we're looking into is surgery in all senses, but starting with orthopedics, what we know. But our goal is going to be expanding to all of healthcare and oncology, heart disease, robotics, and other areas. So going back to robotics, what happened in the past, I guess, 30 years is we had a promise 30 years ago by a company I'm not going to name, where we would have surgery on the International Space Station. And if there are any issues, they'll be able to operate on an astronaut. But that was a bit of a sort of, moonshot. Never happened, but it really led to people thinking about healthcare as a technology platform. And 30 years later, we have robots that work with surgeons and autonomously. And what we really need is that now the technology has been established, we needed to actually do something that the surgeons can't do, which is approach it with an unbiased angle. So that's what Vent is, removing the bias from healthcare and surgery. So the problem today is what you're seeing on the left-hand side. A lot of surgeons, especially in orthopedics, are using X-rays and two-dimensional images to make a lot of decisions on your behalf. So while we're talking about AI agents and everything else, in the operating room we're talking about two-dimensional pictures on a board that surgeon says, well, looks about right. I'm going to cut here and you'll be fine. And what happens is, 20% of the patients are not happy, so they need to come back for revision surgery, which is obviously very invasive. And the healthcare system is suffering because a lot of these surgeries mean, hundreds of thousands of additional dollars to the hospitals to pay, as well as obviously patients to suffer through, and insurance and everyone else has to now pick up the tab because obviously somebody has to pay for all these. What happened in the past, I guess, 10 years is what you're seeing, robots that can actually help the surgeon. I think when a patient thinks robotic surgery, they think robot's going to go in there and start cutting. That's not the case. The surgeon has a haptic feedback. They know what's going to happen, and they sort of make the decision. And if it looks unsafe, they can ditch and go back to normal states. But at the same time, this is a surgeon who's been learning from their mentors the same thing that's causing 20-30% dissatisfaction. So nothing has really been solved. It's just being automated. So it's an incremental technological step that's really not going anywhere. So what we're proposing is, instead of looking at the landmarks that we use because they were sharp points, we can figure out where they are. Why don't we figure out how a human being stands and walks and interacts with the world? So our AI figures out how the patient moves around using kinematic models and physics. We partner with NVIDIA's Inception program. And using those models, we can understand where to reattach a ligament, where your muscle is torn, and how we should operate on you, where to place an implant, etc. Can all be optimized. So the surgeon doesn't have to decide where the implant goes. It's proposed for them, which means they're going to save a lot of time, a lot of space, and they don't have to do extra work that they're not even getting paid for. So they can concentrate on the surgeries, which means 2 to 3 surgeries per day. And as you may know, there are millions of surgeries for orthopedics alone, so it's 2.5 million procedures in the major ones. So it's going to keep growing, obviously, and surgeons are not growing at the same scale. So we need AI to solve all this planning and execution step. So what we're doing with this one is trying to find a solution that is not a silver bullet. They have hundreds and hundreds of parameters they have to think about, and then they're trying to find that one thing that will solve all their problems. It's not going to happen. But with AI, we can figure out all those problems and then find a solution that addresses 5 or 6 points that are going to really make a big difference. So our solution is, from any kind of medical imaging, we're creating point clouds, which you may or may not be familiar from self-driving cars and everything else. We're using it for specifically healthcare, which means that we can find all the different qualities of the bone, ligaments, muscles, all the soft tissues in your body, and then create actual kinematic models you see on the right, and then understand how the human moves, and then what the bone quality is, cartilage quality is, and say, don't rely on this, because even though it looks good, it's actually rotting on the inside or whatever is happening. So that surgeon knows going in, all the risks are being identified, so they don't have any surprises in the OR. And the OR time doesn't just go from 30 minutes to all of a sudden 2 hours because something went wrong. So they're going to know all the different things that can go wrong. They have a plan to execute, and then when they go in, they're going to go in and out, and it's going to be reproducible, which means that you can have a day that has 5, 6 surgeries instead of 2 because something went wrong. So in digital twinning, what we're doing is, as I said, we're moving the body around. So instead of solving for the prettiest X-ray or the prettiest CT scan afterwards, that looks really good for everyone, we're creating a model where the implant goes where it needs to go. So then it's not fighting your soft tissues. So as you're walking and going up and down the stairs and etc., there's a promise that you're going to be able to do those activities without pain. Normally what happens is you get an implant and hopefully you don't have pain, and then you just sort of settle. So we're looking for implants of the future, or even injectables for cartilage repair, etc., where you can actually use these models to understand, is that possible or not, and creates a lot of algorithms that says, you're a candidate for this, you're not a candidate for that. Typical heuristics right now in healthcare is, well, if it's over age of whatever, we're just not going to do that for them. So it's sort of very simplistic and ones and zeros. And you can see the ligament models that we generate. These are all individual fibers, so as they're firing, we know exactly how things are going to work. And then after that, we're creating what's called the kinematic models, and then you can see how the joint moves. And for example, there's an ACL surgery. So ACL surgery right now, just sort of winging it, saying, "Oh, looks about right. I'm going to put it right here." But a lot of the times that fails, so the patient doesn't really get it and end up having arthritis and knee replacements anyway. So with this model, we can figure out exactly where the ligament attaches, attach it for the patient, and then have good outcomes. We have about 50 surgeries now that have been all successful. So there's a lot of sort of threshold of systems that have come, haven't really done anything because they're using old methodologies to build on, versus what we're doing is coming from the other direction and saying, how does a human move? So that's all we got for today. And the future is going to be what you can see in the surgery here. We're showing all those ligament models to the surgeon. So as they're moving the leg around, a bit gruesome, sorry about that. But with augmented reality and with our systems, you can see where all those soft tissues are. So you can say, all right, if I release this soft tissue here, or if I do this here, I'm going to have a better outcome. And they can see that in real time through their glasses. So they don't have to look at screens. They don't have to look at their nurses to see what they should do next. So they can understand all of that. And the OR communication will improve as well. So this nurse or the other surgeon will know exactly what you need before you even ask for it, because they know exactly what you need to do next steps. So there's a lot of economies of scale that's going to be generated from this model, and training will be as well. So any kind of fellow or any kind of surgeon will be trained using these systems, so they know exactly what they're getting into before they even start training.
I'm a co-founder and CEO of MemVerge. We started working on memory-centric AI infrastructure, and today we are actually soft launching a new open source project called Mem Machine, and it is to give AI long-term memory to remember all the historic context as well as personal profiles for all the human-machine, human-human, and machine-machine interactions. So how does AI remember? Today, the first layer of memory for AI happens at the training time. That's when the internet, everything that's public or the universal knowledge is kind of condensed into the transformer model through the training process, and they are captured by those hundreds of billions of weights. And that's all AI remembers. And after training, it does not modify the parameters until the next fine tuning or next training. And so all the data that's private, all the data that's generated after the training time is not captured by the model themselves. The model does have a working memory that's commonly referred as KV cache. Those are really just intermediate data that was generated and to accelerate the inference processing. And there is a lot of context that we are referring to as memory that are not captured. And we believe to make agentic AI happen, that some speakers talked about, having a good AI system that augment what the model does is critical. It's the next frontier. So, so what's AI memory? So AI memory is, it stores, it captures all the conversation logs, or you have been working with AI today. So if you are working with any of the AI models, it does remember automatically during the same chat session. But if you go into another session, it does not remember what you worked on in another session, unless you turn on a particular memory service that's provided by that particular API service provider. And usually those memory only work with that particular model. So, ChatGPT, for example, introduced their long-term memory back in March of 2024, but their memory would not remember the things for another model, for the Anthropic cloud or for your own open source model you deployed yourself. And for a typical enterprise who are looking to implement their agentic AI framework, it is important for this memory to be universal, to be private, to be secure, and that can support multiple agents, multiple models, wherever it goes. The memory needs to stay with the user who those memories belong. And that's what Project Mem Machine is designed to do. And the first two memories we focus on are the episodic memory and the profile memory. The episodic memory remembers all the conversation episodes or events that happened and does the necessary processing and stores them in a spectrum databases, including SQL databases as well as graph databases. And during the query time, the most relevant memory is being retrieved to make the answers from AI more accurate, and to improve the quality and reduce the number of tokens that's needed to get to that quality of the answer. The profile memory, on the other hand, extract from those episodes attributes that's associated with each user ID or each project, each group ID, or each agent. So it captures a profile of every entity, so that the answer from AIs will be more personalized to that person who are making the query. So these are the two memories that we are focusing on, and we are adding additional memories in the future. And it will support all models, all the public models as well as open source models they can deploy. And this can be deployed in the cloud, in your own data center, even on your own laptop. So you can make sure this memory belongs to you. And the most popular benchmark to measure the performance of memory is a benchmark called Locomo. It basically have 10 conversations, pretty long conversations. Then you ask 500 questions to see how much you remember. And the number shows the percentage of answers correct. So there are a number of other memory systems, including provided by those large frontier labs as well as some startups. And now with this open source project, we are demonstrating the highest numbers in terms of benchmark running Locomo. Uh, and we are also open sourcing, in addition to the memory core itself, some sample agents that can do personalized content generation, that can automatically processing the Slack messages and creating customer profiles. And so some of those agents can be useful, but they really serve as samples for you to write agent to do whatever else that can take advantage of what we believe the world's best memory system. So let me give you a simple example how profile memory could work. So this is for a particular application of two financial analysts who are analyzing a stock, whether you should buy or you should sell, or you should hold a particular stock. And in this case, there's Ravi and there's Sophie. Now, every person is built differently. For certain type of jobs, you want different person to give the same answers all the time. But for other type of job, you actually welcome the individuality and diversity of opinions. And different person have their different approach may lead to different answers. And the stock analysis is actually one of those. You don't want uniform answers from all your analysts. Now, in this case, Ravi and Sophie are two different analysts with two different styles. As you can see, Ravi is doing some discounted cash flow analysis. He's pretty technical into the numbers, where Sophie is doing some foot traffic analysis of a retailer, and she is more into the sentiment analysis, mega trend, and so on and so forth. And our memory system on the back end capture these attributes about each of these users. And more they work with AI, the more we learn about them. And then the right attributes are now included as they continue work with AI. So for example, in this case, both of them are asking AI the same question. They are looking at the Wingstop company, looking at the Q2 2024 reports, and asking AI to provide some analysis, some summary. So as you see, with those personalization, it gives Ravi and Sophie pretty different answers, even though it's from the same report. They are not in conflict with each other, but just with different emphasis. Where with Ravi, it's more about numbers, and with Sophie, it's more about mega narratives, mega trends, and so on. And it goes to the point where uh, if it asks on the recommendation, the AI actually gave different recommendation to assist those two analysts. One is neutral, the other is moderate buy, because of the individual personalized attributes. That's different.
Good morning, good afternoon. Stephen Harris. I am with ThoughtSpot. I am our North American Chief Data and AI Officer. By way of background, so first of all, ThoughtSpot was the pioneer in NLQ, so pioneered patent NLQ, and it's the agentic analytics platform. So think about the context of the company as coming from the world of BI, and really making a motion and a movement to deliver intelligence at your fingertips. By way of background, so 30 years in this space, I have had the fortunate opportunity to hold the top data roles at Microsoft, VMware. I was the chief data officer at VMware. I was also with Facebook, so I had my journey there. Spent some time at Wells Fargo, Capgemini for about 18 or so years in management consulting. And so let's see. Just want to make sure I'm on track with the slides here. So this clicker. Okay, perfect. So, when you think about where we are today with respect to AI, analytics, and embedded intelligence, I think the very first question that comes to mind is, what do you mean by embedded intelligence? And how do I take full advantage of it? Who is this message really for? So in terms of product leaders, data leaders, executives, anyone that's really on this journey to autonomous with AI embedded in workflows needs to think about, how do you deliver intelligence at the experience? And that's very different from where we are today. And so when I think about this journey that I've been on, I talked about being in this space for 30 years. And so I started off my career doing SAP implementations. So we've gone from ERP, data being locked in our transactional systems, to data warehousing, where now we move the data into warehousing and built schemas around it for analytics. Then we went from data warehousing to Hadoop, big data. Then we moved to data lakes. Then we moved to the data lake house, dashboards, and of course, this whole experience around how do we actually consume insights at the point of action with embedded intelligence on this journey to autonomous. And so we've built these ecosystems that in some cases have met the need, um, delivering yesterday's news. It's a rearview mirror of what has happened in your business with dashboards being embedded everywhere. And, when I think about that, and I think about it in the context of describing that we are data driven, I'm calling bullshit. Because think about it. We've gone from static dashboards to embedding them. We've consolidated data into environments. We've delivered fragmented tools. Now you have emerging tools, but the other problem that you're surfaced with now is disconnected workflows for the consumer of that intelligence. And so none of it's truly really moved the needle. And arguably, while delivering those insights, these solutions in today's context have been what I would call pacifiers. So how many binkies are we giving out with respect to our insights? Everybody wants a binky. Then comes along this two-letter acronym called AI. Maybe new to some, but not to me. So what's really changed? When I think about the journey that we've been on, I'll tell you what's changed is expectations have changed. Customers now are expecting different things. Each of you sitting here today expects something different. You expect different insights every time you pick up your phone, every time you engage, every time you have a conversation, at every touch point. The question becomes, is that information of value? Is it actionable? How do you make it continuous? How do you leverage that for the purposes of your business? And so, in spite or despite what Gartner has said, I can't see my slides. Oh, here we go. I'm too short. So I step from around them. But despite what Gartner has, in context of what Gartner has said, we've been held back. We've been constrained. All that we have invested, the technical debt that sits in enterprises today is enormous. And those constraints are tied to legacy BI, right? Where structured and unstructured data, trying to bring that together in a meaningful way for the business. Leveraging the combination of first and third party, right? So your internal analytics with external data providers. And then this juxtaposition between AI and BI tools. And so, given those new set of parameters around expectations that we are all now putting in front of those who surface capability to us, whether it be through the product, in an experience, embedded in a workflow, We want it to be instant. We want it to be contextual. We want it to be explainable. We want it to be embedded in every tool. And at the end of the day, this changes things. It's a total game changer. So AI has basically put us in a position where not only are the expectations evolved, how we deliver those experiences has now also evolved. How we govern those experiences, how we secure those experiences, and how we verify and validate that the capability that we're surfacing to deliver is actually doing what it's intended to do. So, what's happening in terms of how we get there? Well, we're breaking all those boundaries because everything has changed. So, think about the time when the first conversation you had about building a dashboard, delivering that dashboard. Essentially, I talked about it being a rearview mirror, right? Looking in the rear view. Today's model and context and framework is now all around autonomous. 10 years ago, none of us actually would have believed that this would be a reality, but today you order it up on your phone and you leverage that experience. And so what's changed is the intent and the need and the ready action to reimagine how we actually land this journey in a meaningful way for the businesses. So it's a movement from dashboard sprawl to action-centric agents. How do you get those agents deployed, governed, scaled? At the end of the day, boundaryless intelligence is about your enterprise's ability to be able to action, deliver, and realize the results and the benefits that come from that. And so I think I'm at time, right? I'm going to wrap up by just saying one quick thing. This is an opportunity, I think, for each of you and your product leaders and your engineering functions to rise to the occasion. So how do you do that? Connect with me on LinkedIn, follow us at ThoughtSpot, and there's more to come.
You've seen it in science fiction for decades. Uploading is the idea that you can scan a person's brain and body and run it in a digital world. Something that's far off in the future that we will never see in our lifetimes. Today, I'll give you a glimpse of an uploaded fruit fly, and it's piloting a drone. We'll see about that, but this is the path. This is on the path to achieving the first human upload in the next 5 years. So what does it take? I don't know if people can read this back there on the screen, but what does it take? 3 pieces. The first is to scan the brain at single neuron resolution, or potentially better, to get the 3D structure. The second is you need to predict the activity of those neurons, or the activation function. And the third is to emulate that organism in a virtual environment. First, the structure, by which I mean image the 3D microstructure of the tissue, primarily neurons and synapses. Today, everyone here is running on cells or wetware. Our consciousness, our thoughts, our memories, our behavior arise from the connectivity, electrical and chemical communication between our neurons and cells in our body. So to image this structure, we first have to prepare the brain. The animal goes to sleep. It's perfused with chemicals to cross-link and harden the cells and lock them away in place. In the case of the fruit fly, it was then sliced up and imaged with an electron microscope and reconstructed to form a 3D model of all the neurons in the brain. We think a better approach is to use expansion microscopy, which makes imaging and reconstruction cheaper because you can use light microscopes rather than electrons, and multi-channel color labeling. After reconstruction of the microscope images, you get a 3D model where all the neurons and cells are and how they are connected. This is what the fly brain looks like. So we then abstracted this into a graph where one neuron equals one node, and synapses connecting neurons are the weights of the edges. Okay, so that's structure. After structure, the second thing you really need is a good neural model, such as how do these cells interact and send messages? What are the activation functions? This is an AI conference mostly, so what are the activation functions? It's a little more complicated than ReLU, but maybe not much. So there are many possible models that you could use. We plan to use very few priors to accept the bitter lesson and to collect lots of data, lots of voltage imaging data to predict accurate neuron activity rather than hand tuning parameters like previous efforts. Okay, so you got these two things. You've got structure, you've got the graph of the connectivity of the neurons there, and then you've chosen a activation function or trained on one, trained a accurate activation function for each neuron. So next is this lets you build an emulation of the fly that behaves like the original. So last year, most people don't know this, last year, one of our founding scientists, Philip Hsu, published in Nature showing emulated fly behaviors with 95% accurate behavior in grooming and feeding, looking at hundreds of different behaviors. So today, I'm excited to share, for the first time, an emulated fly in a body. You can kind of see it on the screen. It's controlled by this scanned brain. We put it in this body and this virtual environment and woke it up. Here we show the activity of the fly as it forages for virtual food, which we show in yellow. The fly uses its visual system to walk around objects and its taste and olfactory system to locate the source of the food. We can predict the activity of all the neurons in the brain. Here we're just showing the activity of a set of neurons in the layers of the visual system. I'm sure you can't see it back there, but the dots, individual dots in those hexagons are single neurons. And there's layers of similar to COMNETs. So information from the visual world is, in the virtual world, is processed by 100,000 neurons in the fly brain, which then sends signals to move the body, which then influences what new sensory information the fly receives. The obvious next thing is, can you give it a robotic body so that it could fly around in the world? So I would love to show you that. There was a little too much wind earlier. We do have a drone that will follow the motor outputs of this fly. Maybe come find me afterwards for the sake of time. So, but really just to say, we connected its movements to control the drone, and because we put a scan of a real fly in a virtual and physical body, the fly can smell, taste, behave like the original fly. We believe we created the first fly upload. So a living, aware, conscious, and digital being, no longer running on biological cells, but digital ones. All right, so where are we going with this next? And also, who cares about flies? What does this mean for us humans? We've already started scanning a mouse. It's a midpoint on the way to scanning and running the first human, potentially in 5 years. So, like a Star Trek transporter, you can migrate from running on cells to running on GPUs. Transistors run 1 billion times faster than neurons. This means more durable, distributed, redundant, and scalable hardware. You don't have to age, you don't have to get sick, you don't have to lose your loved ones. Being digital also means you can upgrade your mind as well, which makes it a safer path to superintelligence and a way for us to stay relevant in a future with ASI. But also, it's just a lot of fun. You can experience hyperreal fantasy worlds or hop back into a robotic body like our prototype fly. You're free to experience eons of love, life, and see the stars. The market for this, we are a startup. The market for this includes any task that humans can do better than AI, and any person or pet still running on cells. I've skipped a lot of details for the sake of time. Just scan the QR code, send me an email. Let's chat here, and yeah, come talk to me if you want to join us on this quest.
Today, I'll be talking about the future of physical labor. My name is Michael Chen, and I'm the CEO and co-founder of a company called Yondu AI. We're deploying autonomous robots right now in warehouses to help automate really repetitive tasks. We're using humanoid robots and training our own robot foundation models to help automate these tasks. Recent step changes in robot learning will usher in the physical AI revolution, with the largest impact on manual labor since the second industrial revolution. So what is robot learning? Well, robot learning is the use of typically large data-driven models that let robots learn from demonstrations, from simulation, and from language, and then use that to generalize to new tasks, new objects, scenes, with minimal reprogramming. So where are we now in all of this? To understand how general purpose robotics will impact the future of physical labor, the closest thing we can look at is the advent of large-scale commercial industrial robot arms within the automotive manufacturing industry. When these arms were rolled out, they had a profound impact on the automobile industry. We saw a 14% reduction in manual labor across the industry. But what we also saw was a 29% reduction in workplace fatalities, a 15% faster assembly time, and over 55,000 new high-skilled jobs being added every single year. What this provides us is a playbook that we can use to help better understand how the advent of general-purpose robotics will actually impact the future of physical work. So what is going to change in these next few years? Well, obviously, existing automation solutions have their limitations. You can take the machines and robots we have now, and they can actually only automate about 10% of the physical labor tasks that are out there across all industries. So what's going to change exactly? Part of this is going to be combining general purpose robots like humanoid robots with robot learning, with robot foundation models. What this will enable is greater automation of tasks. If you took a single robot arm and powered it with the most capable robot foundation model, you could suddenly automate 25% more manual labor tasks than you could with just a typical robot arm. But now let's say you introduce a humanoid robot or something similarly capable, something with 2 arms, a mobile base, a lifting system. What do you get now? Now you get a system that can automate nearly 100% of all manual physical labor tasks that a human could do. But why is this happening now rather than 10 years or 15 years from now? Well, what's changed recently is the rapid commercialization of general purpose hardware. We've seen over the past decade an 85% decline in the cost of general purpose hardware. These robots used to cost over $200,000, and you can buy them now for less than the price of a car. So how close are we to achieving full automation within industry? Well, there's a common misconception that we are many, many years away from full automation. But the reality is we're much closer than people think. A study was recently published from Berkeley that claimed there's a 100,000-year data gap between actually achieving effective humanoid robots. But what it's missing and what most people within the industry are missing is that this is focusing on truly general application robotics. This is thinking about home robotics, a robot that could do your laundry, that could fold your clothes, that could wash your dishes. But when you simplify the problem and apply it to an industrial application where it only needs to do one task really well, that's when everything changes. Because what you can do is simplify the problem enough that you can collect enough data to saturate the space of all possible situations, objects, and environments that a robot could potentially face. You can use that data to train a robot to do that one task really well in any environment, no matter what factory, warehouse, or application you drop it into. Because of this, we're going to see a rapid increase in task automation over time, not starting 10 years from now, starting this year. So what will the landscape look like? Well, similar to how we have OpenAI and Anthropic today producing large language models, we will have similar labs building robot foundation models. These will include companies like your very own Google DeepMind, NVIDIA, Physical Intelligence. These companies are going to produce the models that are used across the world on several different types of robot form factors. And the robot manufacturers that actually build these robots are going to be plentiful. There are already hundreds popping up around the world. But perhaps most interestingly, there will be application layer companies, similar to how you have wrapper companies over LLMs today. My company, Yondu AI, is one of these application layer companies. What we do is we take general purpose robots and we take robot foundation models and we create a service that can be used for an end customer, a business. We help automate a task within industry. So what will be the impact on companies and businesses? Well, the impact economically will be profound. Businesses will become more efficient, and there will be a boom of application layer companies that will rival the explosion of websites during the dot-com bubble. And during this time, there will be several billion-dollar companies that are created in each niche, in each industry across the world in various applications. So a lot of people ask me, is the world going to end? What's going to happen to blue-collar work? There is going to be an incredible impact on blue-collar work. A lot of people, frankly, are going to lose their jobs. But what's mostly going to happen from our initial deployments and our conversations with our customers is not displacement, but reallocation of labor. That's the future that Yondu is building. We're building a future where people are not doing the menial repetitive tasks, like bin picking in warehouses, for example, but instead are doing more cognitive tasks that lean more heavily on the traits and skill sets that humans are very good at: context switching, management, maintenance, oversight. So what is the future of physical labor going to look like? Well, it's going to look a lot different from what it does right now. And it's easy to imagine a dismal, dark future where people are out of jobs, where they have no work. There's also another future which we could imagine, which is much brighter, a future that Yondu is building, a future where people work less. They have lighter work. The work is more cognitive and less focused on repetitive physical tasks. This future will focus on human strengths, and this shift is coming much sooner than many of us would anticipate. So now is the time to plan, to anticipate, to prepare policies and implement the future of physical labor today. We need to plan for a future where robots are as ingrained in society as anything else we see around us. A future where robots are part of every business, no matter how big or how small. Thank you.
AI, predominantly today, it's built on collecting, pre-processing, and curating data sets that are passively ingested and are used for training and inference of the models. This has a huge contrast with the way we think of intelligence in general in the real world, in the physical world, and where we think of intelligence quite differently. We don't narrow it to this task of just ingesting passive data. When we think of intelligence, we are very keen to think about the process of collecting the data. You don't sit passively, idly, hoping the right data will show itself. You go and search for it, and you go and look for it. We all turn our heads to the source of a sudden sound. We bring something close when we don't recognize it, right? So, in other words, for us, intelligence and curiosity are innately coupled, right? So this is, you might ask, why is that the case? And this is fairly simple to postulate as why. Uh, the reasons are very simple to postulate. If you think about the real world, it does not come with an absolute fidelity notion or a resolution that you can apply universally. Each of us in our head hold an adaptive model that captures all the way from subatomic processes all the way to cosmic forces, right? So how do we do that? Despite the fact that our sensing and our sensors, artificially built or our own natural sensors, are subject to physical laws that are rigid and very, very limited in their resolution. Each sensor captures sliver of the world right in front of its field of view and given the resolution that the physics of it dictates. So curiosity, our ability to go functionally and collect the data in favor of one hypothesis or not, is the exact process that we match our physical sensors that are very, very limited in their resolution to the reality of the world, which is infinitely scaled. This is something easy to postulate, but it took me a couple decades as an academic researcher on AI to really prove mathematically. In fact, what I could show using methods developed by Claude Shannon to do fundamental limits of information, to characterize it, to show so long as you start with data that is passive, you will not be able to actually capture worlds that are actually adapt to the complexity of the world. So these adaptive world models that we hold in our head are not going to be realizable unless we let go of this passivity in the data that you're seeing in the current AI models. In fact, the more interesting fact is that if you use this thinking, then curiosity becomes the essence that makes it all possible. You have to let go of passive data, use curiosity to actually build these adaptive world models that we need to interpret and understand the physical world. Now, you might ask me, what does curiosity mean here? And I will get back to it. And that's actually, the answer is exactly the motivation for me to co-found a startup called Cov AI, where we have really studied the process of curiosity. For the purpose of simplicity, let's start with a very grounded example all of us are quite familiar with. You're in a crowded airport. You are very good at tuning on the signs for your target, the gate that you're going, and very good at tuning out the universe of noise that comes your way, from a baby crying to announcements about TSA security and so on. You tune those out, you run to the gate. But if the gate is too empty, something doesn't match up, you don't sit there kind of like passively wait that some information will come your way. You go out and you start hypothesizing what happened, which piece of information did you actually miss, and then using that hypothesis, you get into action. You get into action and you run for the information source that can help your situation, right, and rectify the error. And this is what I call curiosity as really a functionality and not an affective phenomenon. This is the functionality of curiosity. We recognize the sensory information. I missed the announcements about gate change because the baby cried too much, and I recognize this complexity to hypothesize what can I do to fix the situation. And that's exactly what we have done. At Cov AI, we have taken this view and we have generalized it to complex industrial physical systems that really urgently need AI right now. And we have identified two really important components of curiosity. The first one is the understanding of the physical laws and limitations of sensing and multiplicity of the sensors that are at our disposal. you need to know, the AI needs to know what it does not know in order to hypothesize what to do next. Right? So that's the first component. The second component is this closed loop operation that brings information acquisition together with intelligence and reasoning. And that's the second part that we have built. So, and this is the proprietary technology that we have come up with. It's an AI ecosystem that for the first time mimics and provides artificial curiosity by building on leapfrog advances in generative, connected, and embodied AI. And that is why we basically believe this is really going to open up a new frontier for AI to solve problems in the physical world where we really absolutely urgently need it, from seaports and airports, warehouses, refineries, petrochemicals, to really operationalize intelligence in a way that makes sense. So in other words, that's why we believe the future of AI, at least for those who are curious, is going to be active physical intelligence.
Hey guys, my name is Sanjar. I'm a founder of Humanola. So we provide remote teleoperation technology for robots. We support different kinds of humanoid robots and robotic arms that are on the market currently. So if you want to remotely control robots from distance, all you need is just go to our website, teleop.humanola.com, and start teleoperating your own robots. Just plug in your robot. If you don't have it, just let us know, and you can start controlling your robots with a VR headset. So right now, this robot is being controlled by a friend of mine, Alex, from Boston. So this is cross-country teleoperation with very low latency and high throughput. So it's quite an impressive engineering right here. Alex, can you introduce yourself?
I can hear you. Can everyone hear me?
Yeah, they can hear you.
Delighted to be here virtually in robot form. I wish I could have been there in meat body form, but I was summoned for Massachusetts jury duty, so I'm joining you from Massachusetts.
Perfect.
Hi, Alex.
Hello, nice to be shaking hands with you.
Nice to meet you.
Likewise, it's like we've never met, Lisa.
It's like we've never met.
I'll wave hi to everyone. Wave hi with my other hand. Maybe a fist bump for good measure. There we go. So I'll offer two cents, which is this, from my perspective, this is insanely useful for me to be able to telepresently, telerobotically teleport out to the campus in the Bay Area from where I am. And I think in many ways, this is going to be the future of telepresence, to be able to deploy robots on demand, just in time, to events, to work sites. And I think this is a very promising future. So I'm seated comfortably in Kendall Square, Cambridge, Massachusetts, wearing a Quest 3 headset. I have these two controllers, standard hand controllers, and I'm able to control a variety of degrees of freedom for this robot on demand. So back to Sanjar and Lisa.
Does anybody have any questions for us? So I'm a venture partner, managing director with Link Ventures, and Alex is our tech advisor. We're based in Boston, and so he is sitting in Boston thinking, okay, if I want to do work in the Bay Area but want to stay living in Boston, better taxes, he can do it. But Sanjar is focused initially on hazardous locations. Just imagine deploying a robot in a mine and operating it remotely. But ultimately, the vision is for this to be an Uber model, right? And everybody, all of you, to have a robot to do home services work, right? To do any type of work. So, Sandra, tell us a little bit about your vision and what you want to accomplish. This is V1.
Yes. So, yeah, this robot with remote teleoperation capabilities, and we are going semi-autonomous very soon. Um, this technology can be applied in many sectors in the industry. So uh, first of which is obviously we want to accelerate the development of physical AGI or general purpose robotics. The way we do it is we help other robotic startups and research labs to teleoperate robot from anywhere in the world and deploy their robots from day one in real world environments and collect data from those environments where the robot is supposed to operate. So that's going to facilitate early adoption of autonomy or semi-autonomy with remote teleop with human in the loop for edge cases. Um, so and we also provide, other than software, we also provide end-to-end solutions for hazardous, dangerous environments like chemical manufacturing plants. So with that, we should be able to like deploy our own robots like in real environments and collect real-world data. So um, also, as you can see, Alex was really wanted to make to this event, but he showed up in the form of a robot. So it's really cool. So if we currently operate in the Bay Area, if you want to do any of these demos, please reach out to us. We can facilitate this capability. If you want to, if you're somewhere else out of Bay Area, and if you want to attend any event, you can. We can provide this humanoid robot on demand. Yeah. Yeah. Any questions? Yeah. Go ahead. Robots sing for us. Yeah, that's the last thing we want to replace. Yeah. So.
They asked if you'll sing.
So yeah, like.
What would you like me to sing?
Free bird.
No.
Maybe you can sing us a song. I don't know.
How about the wheels on the humanoid robot go round and round? All right, here goes. The wheels on the humanoid robot go round and round, round and round, round and round. The wheels on the humanoid robot go round and round all day long.
Yeah, perfect. Yeah, answering your question again, we want to. Yeah, go ahead. Yeah, go ahead.
Is your company providing like a platform for any robot, or is it like specific for a particular model?
We are providing platform for any robot. We don't have support for every robot in like commercially available, but we currently support three types of robot arms that are most common in the industry, plus two kinds of humanoid robots, which is Unitree G1 and Booster T1. So if you have any of these robots, you can start remotely controlling it right now. Yeah. Any other questions?
Follow up on that. What kind of hardware do you extra need to onboard my robot? Say I have one of the three types that you have. My robot.
What kind of capability you want to see?
Let's say that I have an arm kind of robot, an industry kind of.
Yeah. Yeah, right now we are integrating new types of robot arms
There's no break after this?
Yeah,
as
the
fast as we
flying car's
possibly
coming
can.
up.
So
Copy
Can I
that.
help you?
if you want to see your robot
I'm gonna have one of our
to have
staff.
this
Maybe I can have one
capability,
of our
just reach
staff
out to
grab
us
this
and
right
we'll
away.
easily integrate
I'm gonna
that. Yeah.
What can I help?
Let me think here.
Because the
Questions?
flying cars come up.
Go ahead.
They're
so
gonna bring the flying car up here.
No, the speaker for
The speaker for
flying car
the
is
flying
coming up next.
Okay, let me think here. You know what? I'll get one
Yeah,
of our.
it's part of our IP.
I'll see if I can get Lawrence
As
just
you
to
can
grab some
see,
lunches for us.
No, I can grab it.
like
right
this
here.
is
You guys
being
do it now, 'cause,
teleoperated
people
cross
are
country.
grabbing- I can kind of say
You can
that,
see
say,
the
okay,
camera
okay.
streams
Yeah,
being,
actually,
Colored lines.
being
my biggest thing is
streamed
just making sure
through
that they're in the
internet.
camera.
We have
Yeah, I'm just gonna do a wide shot,
Starlink
even though you can see
mounted
their heads.
to this
Right.
side, so we have internet connection. But the, on a high level, streaming is done through internet.
Your staff or whatever. Just like, sorry.
Actually, this might go.
I did. Yeah, but there's not much left.
All right, any other questions from the audience?
Hey, Ramesh, it's Alex in robot form. Do you have any questions for Ramesh?
Yeah, hi, Ramesh.
Hello, Robot. How are you?
So, Ramesh, this is Alex. Does this update any of your timelines for the singularity?
A little bit, at least by a few months.
Just by a few months.
Okay, I guess the timelines were pretty short altogether, so marginal impact is minimal. I get it.
Yeah. But it depends on what you do next.
It depends on what you do next.
That's true. Well, maybe I should go solve the Riemann hypothesis, or maybe front run Google DeepMind. Thank you, Google, on Navier-Stokes.
I think Navier-Stokes and so on is kind of old news. It's not about solving existing problem. You have to create new problems that we don't even know exist.
Totally agree. So maybe we don't have to wait until next year for Navier-Stokes to be solved.
Yeah. I think that's that's coming to a cliff. But what do you think are the problems that humanity hasn't even thought about solving yet?
Well, I think we're about to see a solution to math, arguably by the end of this year, global solution to math in the sense that most outstanding open problems in math will simply require more compute being piled into existing algorithms. I think we'll see problems in science and engineering start to get solved over the next few years in bulk, not artisanally and not individually. And then I think the main question is, how do we prioritize great problems?
Uh-oh, are you out of battery? Or temperature failure. Okay, we have to definitely deal with the climate issues here. Thank you.
Thank you. It's actually the iPhone, not the robot. So, yeah. So,
Robot called me out.
yeah, the phone heat up and like iPhone. Yeah.
Key differences. One, this one is made of fiberglass, and the one which you see on the news is made from carbon fiber. Two, there is a black plate on this one holding the structure together, and the one which you see on the news is a see-through to allow the air. And three, this one has like a real big wide tires, and the one which you see on the news has actually thin tires for the weight optimization. I'm sure there's a tons of questions. There are engineers, they can definitely answer all these questions. You can ask also me questions. But let me focus why in the world there's a flying car on AI conference. So I'm assuming, okay, I'll talk to you guys, and whoever gets the food cannot listen to that. So whoever trained a model, any kind of model, thank you. And whoever ever flew an airplane, on an airplane, regular airplane, would you put the model which you trained on that airplane to fly for your life? Probably not. And there's a good reason to that, right? Because everything we do depends on one thing and one thing only, which is safety. The only reason any of you will ever buy a flying car if it's safe enough. Safety is actually not a theoretical concept. Safety is a number, which is a 1 in a billion. So if you can get a model to have an accuracy more than 1 in a billion, which is not possible today for any real world models, you can actually fly the flying car with this model. But right now, it's actually not safe. So you should not fly the flying car with artificial intelligence, because artificial intelligence is fundamentally probabilistic and fundamentally fallible. There are way more, right? There's like Alphabet, Google self-flying drive, right? So the difference between self-driving and self-flying is the price of an error. Price of an error in the air is a human life. So this is why you do not want to put AI in the flying cars. Now, that does not mean we do not use AI. We actually do. We have over 10 years and over 1,000 flights with a huge amount of data. So that data is used to train the models and to train the models to enhance the design of the car, the safety of the car, the energy efficiency of the car, which means all the training and all the data which we have is actually enhancing of what the flying car is. And this is actually important. We also have similar capabilities to Waymo, which means we can detect power lines, we can detect landing, we can detect either aircraft or cars. And this is enhancing, but this does not take over flying or driving, which means it's enhancing safety and it's not actually replacing safety. So the important thing about using AI in the flying car, we're a really good example of where AI should not be used. And this is where human life depends on the price of an error. And where AI should be used is this where AI can enhance the actual hardware product. AI and hardware is a completely separate conversation. But AI in design of hardware is what is extremely, extremely important for that. Let me end you with this, that we are a startup, so we are taking investments where you can actually order that car online. We are actually the best-selling aircraft in history by the number of cars sold per year. So we can answer any questions about the car, and any question is a good question. I know there's a lot of hard questions. But again, keep in mind, safety is what is a priority number 0 for us. And the usage of AI has to be driven by safety. Let me take about maybe like 3 questions and then we can walk to the car and answer that. Does anybody have any questions or everybody knows? Sure. Do we have a mic? Do you have a second microphone so we can hear it? No. Okay. Right. So this is why I explained. This is a display model. The display model is exactly the same. So there are videos actually playing here because of the sound. You cannot see it. And on the TV over there, of the actual video of the one which you see on the news. That video, by the way, had 2 billion views, right? This is a display model, right? So there, I started with what's the difference between the display model and the real one, right? But the videos, you're welcome to Google it. That's the right place to say it. You're welcome to Google this, the videos. They are available online, or they're playing on this TV. But this is one-to-one with the one which you see on the news. Good question, and I forgot to say about this. So the question is, how long should the runway be to take off? 0. That's a vertical takeoff. So the reason all the media will read this as a first flying car in history is because that's a first flying car which can actually drive like a car and vertically take off. There has been before cars with expandable wings which needed airport to take off. There has been what is called eVTOL electric helicopters. This is the first car with the vertical takeoff and the only one in history so far. That's the difference. And one more question. Power? Sure. So this is what is called DEP, distributed electric propulsion. So it is 100% electric. There are actually multiple cars which we have multiple versions, and some of them it's actually a hybrid of electric to electric. Because different, remember, so at some point it's a car, at one point it's a rotorcraft, another point it's an airplane. All the 3 modes require different battery requirements. Because of that, there is a hybrid version of multiple types of batteries, which actually best for the specific type of driving rotorcraft or flying forward as an aircraft, and they also serve as a backup to the other battery packs. So you can see that. All right, I think at this point we got it. Anybody who wants to actually see the car, you're more than welcome. I'm gonna go there over there. You can ask questions to me or to any engineers. It's easier to explain it while I'm actually pointing at the actual car. Okay?
We have a question. Question. We have a question.
We can have. We,
Question.
What license do I need to drive that car?
What license do you need? It's actually a very complex question. So to drive, you actually need a driver license. To fly the ultralight version, you do not need any license whatsoever. The LSA version, you need a light sports aircraft pilot license, which is not the same as a pilot license. So for ultralight, no license at all. For the LSA, light sport aircraft pilot license. Thank you, guys.